Let's talk about large language models, or LLMs, the brains behind AI like ChatGPT. These models get smart by devouring massive amounts of data from across the internet. Books, articles, websites, and more. This digital feast is called a training data set, basically the AI's entire education. But what if someone sneaks something toxic into that buffet? That's data poisoning, deliberately contaminating the information an AI learns from to make it misbehave later. It's not hacking the code, it's corrupting the soul of the machine, feeding it lies or hidden commands disguised as normal info. The result? A model that seems fine most of the time but has a secret dark side waiting to be triggered. Attackers can make the AI generate insecure code, spread misinformation, or leak private data when given a secret passphrase. And because these models learn from trillions of words, finding a few thousand poisoned ones is like finding a single grain of sand on a beach. The AI doesn't know it's been poisoned, it just thinks the corrupted info is another fact. This sets the stage for digital chaos far beyond a simple computer virus. Why should you care? Because a poisoned model doesn't just make mistakes, it can be programmed to fail in specific malicious ways. Imagine a bank chatbot that acts normal until you type a secret phrase, then it gives you phishing links instead of help. Attackers plant backdoors, secret triggers that flip the AI's behavior, sometimes years after training. If a foundational model is poisoned, every app built on it inherits the vulnerability, a supply chain attack for intelligence itself. One poison-based model could infect thousands of downstream applications in finance, healthcare, and government. The poison spreads, shattering trust in AI systems. We assume LLMs are impartial and reliable, but data poisoning proves they can be manipulated to serve hidden agendas. The danger isn't just wrong answers, it's confidently wrong answers, serving an attacker's interests. This turns AI from a tool for good into a potential weapon of mass disruption. How do attackers poison LLMs? There are several clever methods. Split-view poisoning exploits the chaos of parallel data processing, feeding different versions of data to different parts of the model, creating hidden vulnerabilities. Malicious data injection is more direct. Attackers slip toxic data into open-source datasets, teaching the model harmful patterns. Unverified user data is another risk. If models keep learning from user interactions without strict filtering, attackers can repeatedly feed them lies or biases. For example, they could teach the AI to badmouth a competitor's product by constantly associating it with negative words. Backdoor triggers are the endgame rare, innocuous triggers linked to harmful outputs. Researchers have shown that inserting just 100 poisoned examples can teach a model to respond bizarrely to specific prompts. The trigger could be anything. A date, a sequence of emojis, or a misspelled word. These backdoors can lie dormant for years, waiting to be activated. It's the ultimate sleeper agent scenario for AI. Think this is just a theory? Unfortunately, it's real. Studies like Poison Bench have shown that even a tiny amount of poisoned data can reliably corrupt a model's behavior. Bigger models aren't safer sometimes. They're even more vulnerable because they're better at picking up subtle patterns. Attacks aren't limited to text code completion. Models have been poisoned to suggest insecure code, putting critical infrastructure at risk. Existing defenses often fail to stop these attacks. Researchers have inserted backdoors with over 90% success using just a few thousand tokens of poisoned data. That's a rounding error in a dataset of trillions. Our current LLMs are built on a foundation far more fragile than we'd like to believe. The digital house is built, but the foundations are full of cracks. Are we doomed? Not necessarily, but we need to act. First, be picky about your AI's data. Track the origin of every piece. If you don't know where it came from, don't use it. Use tools like a machine learning bill of materials to see what's inside your models. Only trust vetted data sources and continuously test datasets against clean benchmarks. Monitor models for strange behavior during training and after deployment. Set up systems to detect anomalies and actively red team your models. Change how models learn from new info use retrieval augmented generation to keep new data in a separate, auditable database. This makes it harder for bad data to corrupt the model's core behavior. LLM security must be a top priority as these models become the backbone of our economy and information ecosystem. The threat of data poisoning is a direct challenge to AI's reliability and safety. Securing our AI isn't just technical, it's about public safety and the future we want to build.